In this video, we are going to look at the difference between the population standard deviation and variance that we've already discussed and the sample standard deviation and variance. If you'll recall, the mean for population mean and sample mean were calculated the exact same way. Well, in the case of standard deviation and variance, we calculate them slightly different. So the sample variance is begun the same way, but in this case what we do is we actually divide by n minus 1. It's called our degrees of freedom. And the degrees of freedom help me know that it comes from a sample instead of a population. I need that little bit of buffer room because I don't have the entire population. The formula for sample variance from a sample size of lowercase n, recall that that is our sample size, is s squared. Recall that sigma squared was our population variance and sigma was our population standard deviation. We have changed from the population to the sample. So the sample standard deviation, the sample variance is s squared and the sample standard deviation is s. If you recall where we talked about mean, mu was the population mean and x bar was the sample mean. You will notice that we have Greek letters for the population and then alphanumeric letters or English letters for the most part for the sample. We start calculating this the exact same way, just in the very end we divide by that n minus 1. So looking at the sample standard deviation, again we're going to calculate those variance and then take the square root of it. Okay? And recall it's denoted by s. So we took the variance and then we took the square root of it. So back in section 3.1 we obtained the following random sample for the travel time data 5:36:26. We want to compute the sample variance and the sample standard deviation time travel time. So if you go back to previous notes where we took this random sample, we had these three numbers as part of our sample. And when we found the mean, we took 67, we added all three of those up, which gives us 67, and we divide by 3. So that means that my mean is 22.3. So this is my mean, 22.3. Then I'm going to take each of these values and subtract the mean from it. So I'm going to take 5 minus 22.3, and that gives me a negative 17.3. 36 minus 22.3 gives me 13.7, and 26 minus 22.3 is 3.7. Then I'm going to square these. So I'm going to take negative 17.3 and I'm going to square it, which is saying I'm multiplying it by itself, and that's going to be 299.29. Now recall that this column must be all positive values. So we're about to take 13.7 times 13.7 or 13.7 squared. That's going to be 187.69. 3.7 squared will be 13.69. These are my three squared deviations for my three data values. I'm going to add these up, and whenever I add these up I get 500.67. I am not finished with my variance yet. Recall that my variance, s squared, takes this 567 and I divide it by n minus 1, I have three numbers, so I'm going to subtract 1. So I actually end up with 567 divided by 2. So my variance is going to be 250.335. Remember, this is the number that I want to use to find my standard deviation. 250.335. And then I'm going to go back and I'm going to round each of these to one decimal place because my data values have 0 decimal places. I'm going to round each of these to one decimal place. So 250.3, and where if I take the square root of this, I end up with 15.8. When we're looking at this, we want to look at some of the properties and interpretations of standard deviation. We don't really use variance as much because recall it was units squared, so this would be actually minutes squared, whereas this one is minutes. So we tend to use the standard deviation more than we do the variance. Standard deviation is a measure of variation of all values from the mean. We say that the standard deviation is the typical deviation from the mean. So the larger the standard deviation, the more spread out the values are. The smaller the standard deviation, the closer the values are. So think of this line as being your mean. If I have a large standard deviation, I'm going to have values out on both sides. But if I have a small standard deviation, they're all going to be very close to that center. Therefore, the red dots are more dispersion, the yellow dots are less dispersion. The value of the standard deviation is either 0 or positive, meaning I cannot get a negative number for standard deviation or for variance. So please make sure that when you square these values, this column always becomes positive. Outliers, and we will discuss outliers, cause the standard deviation to increase dramatically. What we mean by outliers is these values way out here that kind of stand off. Think about in a class, you take an exam, or just think about your particular grades. You have 3 exams and the final. Well, let's say you didn't show up for one of the exams and get a 0, but you made 80s on all the other exams. Your grade decreased drastically when you take the mean of those. Same thing with standard deviation. It's going to increase dramatically because of that one low grade. Vice versa, if you have one high grade like 100 and make 40s on all the other exams, that one grade is actually going to bring you up. The units of standard deviation are the same as the units of the original data. Again, I've kind of explained that because here we have squared the values right here. So it's minutes times minutes, minutes squared, I take the square root of that, that square goes back away, so these have the same units as our original data. And standard deviation is not resistant. Being not resistant, recall, means that any data value will change the standard deviation and could change it drastically, just like we talked about the outliers changing it. So I would highly recommend that you practice some of the standard deviation, population, and sample, and then let me know if you have any questions.